Hello. This video is intended for the Embedded System Design class for the Master students in Electrical Engineering program at Princess Umayya University for Technology. And in this recording, and to try to buy more time to cover more material in the class meeting time, I'm trying this flipped classroom model. But I'm going to use this model to cover something that is not really critical. I'm going to try, I'm actually going to develop with you a program that I used to usually do in class, but this time I'm going to try to do it. I record it, explain, give the needed background, do the class demo, run it, show it to you on video. You watch it, and if you have any questions, we can discuss it in next class meeting. That would hopefully help us move faster and cover more material. So in this recording, I try to be fast and hit the point, but let me share my screen. So this is flipped class demo 2. What we are going to do first, we're going to write a class. We're going to write an assembly program for the HCS12 microcontroller, run it, single step through it by simulation, then put it on the actual hardware and see if it works. What we want to do is to write code to solve a formula that looks like this. For example, Z equals X, let's say Z1, so not to confuse with the register names, equals X1 times Y1 plus W1. Now, X1 is a 16-bit number. Y1 is also a 16-bit number. W1 is a 32-bit number. Okay. So X1 times Y1, the multiplication result will be a 32-bit number. Okay. Then you add it to W1, which is also a 32-bit number. So the result Z1 will be 32-bit. Okay, so Z1 equals 32-bit. In this example, the purpose of the example, we will cover the following instructions. We will use the following instructions. We will use the add instruction, the add with carry instruction. We will use the multiply instructions. We will use the exchange instructions. Okay, and much more. So it's an advance to use what we learned. Some of I know for a fact, at the time of recording this video, we did not cover the multiplication and the addition yet. I'll give a quick background about them. First, the addition, this is where we stopped last class. Let me remind you, the exchange instructions, you transfer data from a register to another register. I explained it in the previous class, in class 10, I think it's there. The exchange instruction exchanges the values stored in between two registers. And then the add instructions, the add and subtract instructions. The first instruction is add A. It adds the contents of a memory location to A. All add and subtract instructions shall use an accumulator, which means register A, B, or D. So one of the numbers that is to be added should be in one of the accumulators, and the other can be in memory. Okay. Or it can be an immediate number. Here is a summary. So the operand here in the add A, add B. So we have add A, add B. If I zoom, so we have first without operand. This is an inherent addressing mode. Add B with A. You don't provide an operand. It adds A with B and stores the result in A. Add B to X and store the result in X. Add B with Y and store the result in Y. The add A with an operand, it can be an add with carry. So it adds A plus the operand plus the carry flag in the CCR register and stores the result in A. So this C is for carry. Add with carry. You can add with carry to B, or you can add an operand to A without carry. So add A. Add to A the value of in the operand, which is usually a memory location. Add to B or add to D. Here you're adding 8-bit to 8-bit. Here you're adding 16-bit because D is 16-bit. Okay. The subtract, almost the same. Subtract B from A, subtract with borrow from A and operand. So this will subtract an operand from A and borrow. It would subtract the carry. And so on. Here are the add and subtract instructions. The multiplication instructions. We have different kind of multiplication and division instructions. We're going to cover them in class, but what we want to know here, there is an emal instruction. This multiplies unsigned 16-bit by 16-bit, and the result is 32-bit. Here you don't provide an operand. The operand has to be register D and register Y. So the two numbers you want to multiply, one of them you put it in D, the other in Y. Then the result, the 32-bit will be in D and Y. Lower 8-bit of the result, lower 16-bit of the result in D, higher 16-bit of the result in Y. Okay. Emal is for signed numbers. Okay. Mul is for unsigned 8-bit numbers. So in our multiplication example we want to do today is multiplying 16 unsigned numbers. So we're going to use the emal. These are for the division. I'll cover them later. Okay, so the emal D times Y, and Y in D stores the result. So, okay, so here we have the add accumulator A instruction, add accumulator A, here it is. Okay, add A, add B, add D, and add CA, add CB. Let me write them down. Sorry. Add A, add B. Is it like that? Yes. Add D, add with carry A, add with carry B. There is no add with carry D, okay? The multiply, we're going to use the emul instruction for unsigned 16-bit multiplication. Okay, here one of the operands has to be in register D as per the sign here, D times Y, and the result will be stored in this order. The higher operand, the higher, where is it? Here, the higher 16-bit is in Y and the lower is in D. So Y, D. Mashi? So this is the thing. So going back to the equation we want to solve, x times y, x1, y1, w1, let's assume they are in memory like this. Here's our memory, data memory, SRAM. We start at address 1000. So what we are doing right now, before writing code, we're planning for our program, right? We need to plan for our program how to write it. So we start here. Let's store, for example, x1. x1 is a 16-bit number, so it takes 2 memory locations. So do you want to give them values? Let's say x1 points here, and it's 16 memory locations. This is x1. Okay, and I don't want to make it a pointer. It is actually a label. It's not a pointer, so not to confuse. So we want to call these 16 bits x1. Okay, then we have y1. Let's store it. It's also 16-bit here. y1. Then we have w1 32-bit, takes 4 memory locations. So 1, 2, 3, 4. These are w1. Okay, we'll compute the numbers later. Then z1, it's going to be 32-bit, so we need to book or reserve 4 locations for it. 1, 2, 3, 4. These 4 locations will be z1. So if we give them numbers, this would be address 1001, 1002, 1003, 1004, 1005, 1006, 7. This is just to help us debug through the program later and better understand it. 100A, 100B. Okay, the numbers, do you want to assume numbers? Let's assume if x مثلا was $1, 2, 3, 4. So x1 equals $1, 2, 3, 4. y1 equals مثلا example 5, 6, 7, 8. So this will be 5, 6, 7, 8. W1 is I don't know 9, 3, 2, 1, A, 1, 2, 3, 4, 1, 2, مثلا 0, 0, 32-bit number. So W1 will be $9, 3, 2, 1, A, 0, 0. Z1 will be used for the result. Let's go write our program. Okay. Before going to Code Warrior, how do we want to approach this? First, we need, let's say step 1, load to register. We want to do the multiplication. So this is step 1, multiply. Then step 2, we add. Okay, so step 1, let's do the multiply. To multiply, we know that the two numbers we want to multiply, one of them should be loaded to D, one of them should be loaded to Y. Okay, so we can do this, load D with the first, load D with the D would carry X with X1 مثلا, and load Y with Y1, then 3, say E multiply. The result here will be Y and D will have the result, the X1 times Y1 result, right? Now, D is the lower 16-bit and Y is the higher 16-bit. This is to be added with W1. This is step 2. To be added with W1. So as W1, we're adding here, don't forget, we're adding here 32-bit number, 32-bit, right? 16 plus 16. So let's assume that W1 high and W1 low. And we add D to W1 low and Y to do W1 high. Okay, so then we want to add D with these. We want to add D with these, right? And then add Y with the high by 16-bit, right? Of add it to Y here. Tamam? After we add this and this, well, the addition of 16-bit, remember, when you add 16-bit to 16-bit, we're going to run into an issue. For example, if you add 32-bit numbers, let's add, I don't know, we need to consider the carry. That's the point I want to get to. So if you want to add 1, 1, 1, 1, 0, 1, let's say 1, 1, 0, 1 plus 1, 1, 0, 0, 1, 0, 1, 0. If we want to add to these two numbers, 1 plus 1 is 1, 0, sorry, is 1, 0 plus 1 is 1, 1, 1 plus 1 is 0, 1, carry 1, 1 plus 1 plus 1 is 1, carry 1, 1 plus 1 plus 1 is 0, carry 1, then 3 ones, 1, carry 1, then 1, 1, 1 is 1, carry 1. This is the carry flag. So assume this 8-bit number is in register A, مثلا. this number is a register A, and this is an operand in memory, for example. We added them, no problem. طيب, if there is the number is a 16-bit number, so you can add 16 plus 16, right? You can add D plus an operand, 16-bit operand, the 8-bit operand, no issue, no issue. طيب, what about if I want to add D plus a 16, let's say I want to add 32-bit plus 32-bit. 32-bit plus 32-bit, then you have a byte 2, 3, 4, with another byte 1, 2, 3, 4. So you add the first byte with the first byte, right? Whatever carry goes from here to here has to be added to the second 2 bytes when you add them, right? So if this is an 8-bit register A مثلا, it is easy to add this A with this operand plus carry, right? You say add with carry A. It is easy. But there is no instruction that can add the 16-bit together with the carry with another 16-bit. Okay, that's why if you want to consider the carry, you cannot ignore the carry. After adding the first byte, you start adding bytes. You cannot add 16 bits if you want to consider the carry, if the number is a big one, not separate numbers. Okay, we need to make sure to keep that in mind. So when we add the results, D plus W1 low, let's call it R1. Okay, this is the low 16-bit of the result. We store it here in the low 16-bit of Z1. Then when we add Y with W1, we need to add to it the carry that resulted from adding the first 16-bit, the carry. So the carry has to be added here. So I cannot add Y with W1 altogether with a carry, because there is no instruction that adds 16-bit to 16-bit with carry. So here I need to split these. So Y low, Y high with 8-bit and 8-bit, and always consider the carry. Okay. So let's go first implement this memory map in our code. Okay, and start writing our program. طيب. Let me start a new project. Run Code Warrior. So file, a new project. We use the MC9 S12 DG to V6B, just like last time. We don't want to write to C. We don't want to write in C. We want to write in absolute assembly. And we want to store this project and create a folder for it. For example, let's call it class demo 2. Okay. Save. Next. Next. Finish. Here we go. Our main.asm. Here we delete these data booked from the demo, and then here's our main loop. Let's delete all this. Okay, and here we write our main code. First, let's book the memory map. This one, this drawing. You know what? I want to put it on my other screen just to make sure the numbers match, so I can look at it. Okay, so origin RAM start is 1000. So the first thing we do here is gonna be stored at 1000. So X1 is gonna be a 16-bit number. So we can say define X1 here. Okay, we don't, because it's a label, we don't, we start from column 0. So X1, define constant word, and the number we put in there was, in our example, 1234, right? So $1234, okay. Then what happened? Oops, I pushed the page one. Okay, the other number is Y1, comes immediately after it. We can do define constant word as well. Define constant word, and the number here was 5678. 5678. Then we have W1. W1, you can do 2 words, or you can do 4 bytes. Let's do 4 bytes just for any change. So we can do W1 because it's 32-bit, define constant byte, but we're gonna book 4 bytes, yani 32-bit. So the first one was what? 93, comma, $21. I'm just copying from the notes we just wrote before starting the program. Then 21, what? Then AA, then $00, 00. This is a 32-bit number if we deal with it all together. We just place the bytes in memory as, well, let me put it here. Oops, what happened? What happened? Why did this hide? Okay, what happened here? Actually, sorry. So what I did right now is this, is what, why it jumped, I don't know why. Here. What I did is, come on. Okay. Okay, it put them together next to each other. See what I did? Here, X1, here's X1, Y1 in the drawing, here's Y1, W1, here's W1. Okay, we need to also book 4 locations for Z1, and we didn't do that. So we can say Z1, we don't have the value, so reserve memory bytes, 4 bytes for the result. Okay, this is what I did. Now let's start our program. But let me enlarge this, take this away. And enlarge this. Oops, what did I do? Okay. Then now we're ready to start writing our code. We go at the RAM start. We can leave this initialization of the stack pointer, no problem. This is our main loop. First thing we said we were going to do, I'm still looking at the steps we wrote. We need to load X1 to D, right? So we can say load D X1. Here, register D will take X1. That is 16-bit, matches size, so no problem. Then the other operand that we want to multiply X1 with Y1, one of them should be in D, the other should be in Y. So we load register Y with the number Y1. So here, register Y would include the number Y1. Also size matches, 16-bit. Then we multiply, we say emul, that without operands, that's it. This would result that Y, register Y, and register D, 16-bit and 16-bit are 32 bits, will include the result of multiplying X1 times Y1. Tamam? So the result will be in Y and D. طيب. So the multiplication is done now. What did we do after the multiplication? Now we need to start adding with, so we want to do here, what we want to do here, this program is to store in Z1 the result. Let me put a comment just to remember what you want to do. Z1, store in Z1 the result of multiplying X1 times Y1, then adding W1. ماشي? Where X1 and Y1 are 16-bit numbers and W1 is a 32-bit number. ماشي? So Z1 will be 32-bit يعني for sure. طيب. So now we have the result in Y and D. We need to add D to the lower byte of W1. طيب, W1 is somewhere in memory. We need to add it to the lower 16-bit, which is this 16-bit that come here. So again, let me show you the drawing with these, right? So if we make a pointer point to W1 X here, register X, if we make register X point here, we want X, comma, so the index, if we use the index register addressing mode, we want 2, X, right? 2, X will be pointing here. Okay. And okay. So what we want to do now is to make a pointer point to W1. To W1. So let's make register X point to W1. Okay, so we load, what did I do? Where am I typing? Here, okay. Here, we want to load X, we want to make X point to W1, load X with the address of where W1 is stored, so immediate, okay? Immediate W1. Why immediate? If I said load X with W1, it will go to W1 and get the contents of the memory location where W1 is. But no, I don't want the contents of the memory location. I want the actual address. In this case, it's going to be address what? Yani, what is the result of X after executing this load X with W1? It will be this number, 1005. Is it the, when? W1? No, 1004. It's going to be 1004. Okay, so we're loading the address, not the contents. طيب, now X will point to W1. Okay, so X will be X, يعني هنا X register will point to W1, i.e. X will have the value $1. What will be here? These are 1000, 1001, 1002, 1003, 1004. $1004. Okay, so we're making X as a pointer. So we loaded X with the memory location where the W1 is at. Now we want to add the lower 8-bit of W1 with what? With D, right? So we add D here. We add D with 2 comma X. صح? X is pointing to W1. But I don't want the first 2 bytes of W1. I want the next 2 bytes. So W1, so X plus 2, not plus 1, plus 2. And since we are adding to 16 bits, so it will take plus 2 and plus 3 as a word and add it to D, right? Here, what we did, we're storing in D the result of adding D, which had the lower 16-bit of the multiplication, plus the memory location pointed to by register X plus 2 as the higher byte, and register X plus 3 as the lower byte. Okay. Right. Now this is done. This result is ready. We can go store it at the result Z. We can just go and store it here, R1. This is R1. We can just store it here at 1000A. To store it here, we can do something just like we did with X. I'm avoiding to use register Y because why? Because Y still is holding part of the multiplication result. So I need to use X again, make X point here, and we store at here where 2 comma X points at. ماشي? طيب. Now, I want to store D first. Before storing D, I want to make X point to the result Z1. So load X immediately with the address of Z1. So here Z1, sorry, we're loading X. So here X will take the value of the lower of Z1. So what is the value of Z1? So we said this is address 1000, 1001, 1002, 1003, 1004, 5, 6, 7, 1008. 1008 is the first memory location of Z1, 1008. Now X points to the result. I want to store D in the memory location, in the lower, not where X is pointing at, the lower, the following word, okay? The following third and fourth bytes of where X is pointing to. So we say 2 comma X, okay? So here we stored at memory location where X is pointing to plus 2 and X plus 3, 2 memory locations, 16-bit. We're storing here in this memory whatever was in D. Whatever was in D is the result of the multiplication, lower 16-bit of the multiplication added to the lower 16-bit of W1. So we finished the first half. Now we're going to work on the second half. Y1. Now we're done with D. D doesn't have anything that we need to care about anymore. We can exchange D with Y. Exchange D with Y, right? So the lower 16-bit of the multiplication now are in D, okay? So we transferred or we exchanged. Now D includes the higher 16-bit of the multiplication. Okay, now we want to add to D the higher 16-bit of W1, but we cannot plus what? Plus the carry that resulted from adding the carry that resulted from this operation. But I cannot add to D an operand memory plus carry, because we saw here that the instructions that can add the carry are add with carry A and add with carry B. There is no add with carry D. طيب. So I need to add 8 bits now instead of 16 bits. يعني I add with B, then add with A. ماشي? A is the higher byte. So what we do now, again, we want to make X point back to Y. So we load X. Sorry. So we load X with immediately, sorry, with W, immediately with W1. تمام. Let me check the map again. Okay. Map. Yes. Here, W1. So X goes to W1. Sorry. Okay. Now what happens here is that X points to W1. Register X points to W1. So يعني X شو راح تكون فيها هون؟ X will be loaded with the value of W1. So we said one here, 1000, 1001, 1002, 1003, 1004. So 1004 again. 1004. طيب, we made X point there. Now I want to add a byte, but مش the highest byte, the one below it, with the carry that resulted from the previous addition, the previous 16-bit addition, plus what? Plus the lower byte of the multiplication that is in D now after the exchange. يعني اللي هو ايش B, which is register B. So we add with carry B. We add with carry B 1 byte less, and not the most significant byte, the one below it, 1 comma X. X is pointing to W1. Okay. Then after this, we add the other byte plus the carry resulting from this addition. So we add with carry A, but this time 0 comma X, the most significant byte of X. X is pointing to W1. Now, B and A have the result of adding register D, which is the higher 16-bit of the multiplication, plus the higher 8-bit, 16-bit of W1. It's ready in D. We just need to store it. Where do we store it? We store it in the higher 16-bit of Z1, but we need to make a pointer to Z1, or we just, we don't need to. We can just say store D at Z1, okay, because 16-bit directly as is. Okay, then we're done. Since we're going to put this on the microcontroller, let's turn some LEDs on. So let's let's turn the 7-segment LEDs on and the red, green, blue LEDs. The red, green, blue LEDs, if you check the schematic, are connected to port P. So if we make port for the 7-segment display, move byte, make the register, the port output. So we put 1s in all the bits. So move byte immediately $FF to DDRH, make port H, just to see something on the board, port H output. Then turn on the LEDs. We said it's a common anode, so we write zeros to turn on. So we move byte immediately zeros to port H. This will turn on all 7-segment LEDs. طيب وبورت بي كمان رد جرين بلو. يلا so let's make port B move byte immediately. Let's make port P output FF DDRP, make port P output. These are connected added to the anodes to the pins, so we write ones to turn them on. So we move byte immediately ones. They are connected to port 456, I think 456. But it doesn't harm. We can turn them all on. So we can say move byte برضو FF immediately FF to port P or PTP. Then get stuck here forever, infinite loop, branch to forever. That's it. Let's build our program. Any errors? Yes, we do have errors. X1, there's a problem with X1 type. X1 could be a space issue. Yes, we can just remove this space for the label. Build again. Okay, here DDRP is not known. Let's make, what's the problem here? Value is turned to 5 bits. Okay. 5 bits. The schematic, if I want to check the schematic, here, the schematic, I checked it. Here's the schematic for port P. Here, port P, where is the LEDs? Red, green, blue LEDs. Red, green, blue LEDs. Where are they? Here they are. Red, where are they? Again, here they are. Here are the red, green, blue LEDs. So they are connected, they are connected with current limiting resistors to port piece 456. Okay, let's make only these 456. 456, if I wanna 456. So 0, 1, 2, 3, 4, 5, 6, 7. These are the red, green, blue. So I want to make these output. So if everything else is zeros, so I want to write a 7, 0 here. 7, 0, and also turn them on with a 7, 0. So 7, 0, and turn them on as well, 7, 0. Will this work? Okay. طيب. Register expected $. Maybe the name, let me just check it in the derivative. Control F, port P. Here, PTP. طيب, what about the direction register? PTP, Control F, PTP, Control Z, Control F, Control F. طيب, it should be somewhere. DDR, PTP, DDRP, DDRP here. طيب, DDRP, DDRP, PTP. This is correct. Semicolon. Oh man, semicolon. Okay, everything is good now. We can run the full chip simulation. Here's the full chip simulation. You can single step through it and see how the registers are done. If you want, before we do, we can just go do with the calculator, check our numbers if you want. Do you want it? Let's do it. Let's check with the calculator. Where's my calculator? To compare hexadecimal. So we want to multiply hexadecimal 1, 2, 3, 4, multiply it with 5, 6, 7, 8, 5, 6, 7, 8. The result is 32. And then we add to it 9, 3, 2, 1, AA, 0, 0 equal. So this number, I'm gonna copy it and put it here and put it here just to compare with. Or you know what, just the calculator is still there. Yeah, still there. We can compare. It's 9947 AA60. طيب, let's go to our program. You can single step through it. I'm gonna just hit the run button and see the results. The result is in Z1. Here's Z1, right? Z1, I wanna see hexadecimal format. Here, because we booked 4 bytes, it's 4 bytes, but we can go to the memory location. We know that this is at address 108 is for W plus 4, 9. Well, it's in the map here. So Z is at, starts at 8. Yes, 1008, 1008. So 1008. So here are the results. 97AA60, if you compare it with what's here, 99 in the 9947 AA60. So our plan algorithm for adding and multiplying the numbers has worked. If I want to put this on the microcontroller, I can do that. Here, let me see. I turn to load mode with the dip switches. ماشي. Load mode, hit reset. Then here we close this. Choose serial monitor, program, COM3, I remember it was. Okay, not COM3. Device manager, device manager. Open this one. Not this one. You know what? Let me just go to my computer and just go to this PC, right click, device manager, manage, or was it manage or properties? Manage. Yes, device manager here. Here I can see the COM ports. It is COM3. Why is it not working? Okay. COM3, load, reset, Mashi power, COM3, okay. Again, let me try again. Okay, something stuck. Close this one. I have to close this one. Close the program, Mashi. Okay, sorry for this. Man, this took time. I'm glad we're going to be saving this time for other topics in the class. Let me close Code Warrior. I know the code is stored. Come on, what's going on? You know what? File. Can I close all? Close. I want to close everything here. Why is this still running? Close. I want to run this one again. Load my project. File, open my project. That is class demo 2. Here, open it, open. This is my program. Load, reset, run, dismiss. Okay. Okay, something stuck on my PC. I'm sorry. This is not responding. Serial monitor. Okay, let me take. Okay, I took out. Okay, I took out my USB. I'll put it back again. But let me just solve this issue. Cancel. Okay. Close everything. Okay. Cancel. Okay. 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 Cancel. Okay. Play. I'll put back my USB. Load. Reset. Serial monitor. Run. COM3. It is programming. Okay. Turn to the run mode. Hit the reset button. And here you go. I'm going to stop sharing to see a bigger version of me. So the LEDs, where is it? The LEDs are here. The 7 signal display is on. I don't know if it's clear in the picture. And here are the red, green, blue LEDs are all on, mixed colors. Thank you very much. Hope this was useful, and see you next class time or next demo. Have a great day.